Today I'd like to talk about the real number system. We've already talked about rational numbers and irrational numbers, and we'll touch on that again today, but the real number system, let's talk about that. The real number system is made up of all these things. So let's review natural numbers. Natural numbers are your counting numbers, okay? That when you were first learning numbers, you started with 1, 2, 3, 4, and so on. When we talk about natural numbers, we're talking about the counting numbers which you first learned. Whole numbers is the set of counting numbers, but we're going to include 0 this time. Okay? So the only difference between natural numbers and whole numbers is that the whole numbers include 0. Alright? Integers, as we remember, integers is a set of whole numbers and their opposites. So it's all of these numbers above, 0, 1, 2, 3, 4, 5, and beyond, okay? And it's also their opposites. And remember, opposites are a number that's the same distance from 0 on a number line, but the opposite direction. So the opposite of positive 1 is negative 1. The opposite of positive 2 is negative 2, and so forth. Notice, none of these integers have any parts. There's no 1/2. There's no 0.3. Okay? So it's the whole numbers and their set of opposites make up the integers. Alright? The next set of numbers are rational numbers. And as we remember, rational numbers are any number that can be expressed as a fraction. So let's take a look at these. We've got 2.375. I can write that as a fraction. And also, it is a terminating decimal. It ends. It doesn't go on and on and on. 4 is a whole number. All whole numbers are rational numbers because I can make it 4 over 1 and write it like a fraction. 0.25, that's one of those common decimals that we know the fractional equivalent to. So this is 1/4. So it can be written as a fraction, and it's also a terminating decimal. 3.7, we can write that as a fraction. It'd be 3 7/9. We also know that if a decimal repeats, it can be written as a fraction, therefore it is a rational number. We know that rational numbers were numbers that cannot be written as a fraction, okay? And their decimal form neither terminates or repeats, okay? So pi, remember, is just it's a non-repeating, non-terminating decimal. The square root of 3, well, the square root of any number that is not a perfect square, okay, that is an irrational number. Here we have a number, a decimal, and it says 0.14114114, and it has these dots after it, which means this pattern continues forever and ever and ever. You notice the pattern didn't repeat, it just continues. It's adding 1 each time you go. So this one would be a non-terminating, non-repeating decimal, which makes it an irrational number. Today we're talking about real numbers. Real numbers are the set of all rational numbers and all irrational numbers. So everything we've talked about above in these notes is considered a real number. And yes, there are numbers that aren't real, they're imaginary numbers, but that's a subject for another day. Let's take a look at a chart here, and hopefully maybe this will help explain a little bit. I've got kind of a Venn diagram, and it's the set of real numbers. Remember, real numbers are the rational numbers and the irrational numbers. And each in the rational numbers, we have integers. Okay, remember, integers are the set of whole numbers and their opposites. Then we have whole numbers. Okay, whole numbers are counting numbers plus 0. Then we have our natural numbers, which are just our counting numbers, 1, 2, 3, 4, and beyond. Okay, let's categorize some of these numbers I have up here. Right here I have the negative square root of 49. Well, 49 is a perfect square. The square root of 49 is 7. So this is negative 7. Well, negative 7 can be written as negative 7 over 1. But it can negative 7 also fits the category of an integer. It's the opposite of a whole number. Okay, so I can put it in this category. So Rational number is a great big category. I just put it in a little bit smaller category, and this is the best description of the negative square root of 49. Next we have a decimal up here, and it's negative 5.3125. Well, it's a terminating decimal, therefore it's a rational number. Okay, can I put it down in with integers? No, because remember, integers are the whole numbers and their opposites. This is not a whole number. This number has a part. So I'm going to leave it up here in just the rational area. Let's take a look at this number, pi. Well, pi right off we know is an irrational number because it's a non-terminating, non-repeating decimal. Our next number is 2.06532. All right, it's a terminating decimal. If it's a terminating decimal, it's a rational number. Well, does it fit the category of integer? Is it a whole number or its opposite? No, it's not. Therefore, we're going to leave it just in the rational number zone. Next thing we're going to pull down is the square root of 324. Well, 324, the square root of 324 is 18. Okay, well, 18 is an integer. Okay, 18 is a whole number. Now, 18 is also one of our counting numbers, our natural numbers, because that was one of the numbers we learned to use when we were first counting. So I can put it all the way down into this small category of natural numbers. All right. Our next number is the absolute value of negative 24. Well, remember, absolute value is just the distance from 0. Well, negative 24 is 24 steps away from 0. So 24 is a integer. It's a whole number. Is it a natural number? Is it one of the numbers we learned to count with? Is positive 24 one of our counting numbers? Yes, it is. So we're going to take it all the way down into natural numbers. Our next number, or actually it's an expression, says negative 3 minus 3 squared. Well, 3 squared is 9. 9 minus 9 is 0. Okay, so 0 is a rational number because I can write it as 0 over 1. It's an integer because it's a whole number or its opposite. It's a whole number, remember, because whole numbers were the natural numbers, the counting numbers, plus 0. Is it a natural number? No, because the natural numbers do not include 0. So we're just going to have to leave it up here with whole number. Our next one is 4 to the negative 2 power. Well, we remember if it has a negative exponent, that if we take the reciprocal of that, we can make it a positive exponent. So really this is 1 over 4 to the second power, which simplifies to 1/16, which would mean that's a rational number because I can write it like a fraction, okay, but I cannot write it as an integer, a whole number or its opposite. Okay, our next number is 0.592 repeating. Well, remember, if it's a repeating decimal, it is a rational number, but it is not an integer because it's not a whole number or its opposite. So I'm just going to leave it hang out up here with the other rational numbers. Our next number is the square root of the negative square root of 95. Well, is 95 a perfect square? No, it's not. Okay, so if it's not if we're taking the square root of a number that's not a perfect square, we're going to drag it over here to our irrational numbers. All right, here's 0. Well, I can write it as 0 over 1. Is it a whole number or its opposite? Yes, so it's an integer. Is it a whole number? Yes, so I can drag it on down into whole numbers. Is it a natural number? Is it one of our counting numbers? No, the counting numbers start with 1. Okay, so we're just going to have to let it hang out there with the whole numbers. Our next one is the square root of 144. Well, the square root of 144 is 12. Well, 12 is an integer. 12 is also a whole number. Is 12 one of our natural numbers? Was it one of the numbers we learned to count with? Absolutely. Okay, so we're going to drag it down in here to natural numbers. Next, we have negative 17 over 4. Well, it's written like a fraction. Okay, Is it an integer? Well, let's simplify it. 4 goes into 17 4 times with 1 left over. So this would be -4 and 1/4. Well, that means it's not an integer because integers are whole numbers and their opposites. So I'm just going to leave it hanging out here with the rational numbers. Next, we have 30 over 3. Well, 30 over 3 is a rational number because it's expressed as a fraction. If I simplify it, it reduces to 10. Well, 10's an integer. 10 is also a whole number. And 10 is also one of our natural numbers. It's one of the numbers we learn to count with. Okay? We go on up here. Our next one is the square root of 9 over 16. Well, the square root of 9 is 3. The square root of 16 is 4. So this is basically 3/4. Okay? Well, 3/4 is a natural number, rational number because it's a fraction. It's expressed as a fraction, but it's not an integer. So we're just going to leave it hanging out here with our other rational numbers. Okay? Our next number is the cubed root. Cubed root means what number times itself, okay, equals our number. Well, this cubed root of -125 would be -5. So -5 is a rational number. It's also a integer, okay, because -5 is the opposite of the whole number 5. But I can't bring it down into the whole numbers. I've got to leave it there, okay, because it's not a whole number, because it's a negative. And remember, whole numbers are 0, 1, 2, 3, 4, 0, and the natural numbers. My next one is the absolute value of 13. Well, the absolute value of 13, but we've got this little negative sign out here, which means -1 times our answer. Well, -1 times 13 makes it -13. Well, -13 is a rational number because I can put it over 1. It is an integer because it is the opposite of the whole number 13, but it's not a whole number. Remember, whole numbers, 0, and the natural numbers. Okay, our last number for today is -1 and 2/7. Well, it's expressed as a fraction. Can I drag it on down into integers? No, integers are the whole numbers and their opposites, so it's not going to fit. So we're going to leave it hanging out right there. So when I look at this, under rational numbers, the smallest group of numbers are the natural numbers. Okay, there are counting numbers. Okay, whole number would be our natural numbers plus 0. So this group, the whole numbers, is just a little bit bigger than the rational numbers. Okay, integers include all the natural numbers, all the whole numbers, and the opposite of the whole numbers. All right, rational numbers include any number that can be written as a ratio or a fraction. They include terminating and repeating decimals. Okay, irrational numbers are numbers that cannot be expressed as a fraction. They include non-terminating and non-repeating decimals. And these two groups together form the real number system. Well, I hope that helps a bit, and look forward to answering any questions you might have. Have a good day.